right, let's try this again. All right, I'm going to type in that equation. 3x to the 5th minus 2x to the 3rd plus 6x squared minus 4. Why is this so difficult for me to do today? Minus 4. Okay, then I'm going to graph it. So this is exactly the same way it's going to be for your test, right? So I said it yesterday, but I'll remind you again that the first part of your test is going to be calculator based, okay? It is worth 25 points, and it is all based on this graph, like whatever graph you get. So you want to make sure that A, you know what you're doing when it comes to your calculator. B, you do it carefully, okay? You want to make sure that it looks like what you think it's supposed to look like. So this gives me the overall picture, right? So I'm going to come over here and I'm going to draw in as best I can this picture. It doesn't have to be perfect, but I can't see what you got on your calculator when I go to grade your test. You need to show me what you got on your calculator. Does that make sense? So I'm going to come over here, and this is going like in between -1 and -2, and then back in between 0 and -1, and then 1, 2, 3, 4, around 4, and then around 1. So again, it doesn't have to be perfect, but something similar to what you're seeing in your calculator is what you want. Now I need to use my calculator to find the zeros and that kind of stuff. So before I close out this window, I'm going to do that. Domain and range I'm going to go back to, okay? But I need to find those points where the maximum is. I need to find the zeros, okay? So I'm going to go second, trace, and I get to this menu. I'm going to go to 0. Enter. I'm going to go left of my first 0. So there's 3 zeros on my graph. I'm going to go left of that first one. I'm going to hit enter. Then I'm going to go right of the first one, but I can't cross into the second one's space. I have to go right to of the first one. Hit enter, and then it's going to guess, and I'm going to hit enter again. And it's telling me that that 0 is at -1.25. So this point here is -1.25. Actually, 1.26. I'm pretty sure on the test I say to round to the nearest tenth. So we would round that to -1.3. Then I want to find the second 0. So I'm going to do it again. Second, trace, get to the calc menu, go to 0 again. This time I'm going left of the second one. Then I'm going right of the second one. And then I'm hitting enter to guess. And that point is a 0.816. So this next one would be 0.8. Then I want to find the last one, second trace, 0, left of it, right of it, bring me there, and it's a positive 0.8. God bless you. The last thing I need from this are the max and mins. There's one relative max and there's one relative min. So I go second, trace, I go max. I go left of my max. I go right of my max. I guess. And it brings me to that coordinate point. So the max there is -1.07, so 1.1 and 1.1. And then the bottom point, or the min, second, trace, min, go left of it, go right of it, and I get that point is, now that says 4.7 e to the -7th and -4. What does 4.7 e to the -7th mean? How many of you are in chemistry? It means there's 7 zeros in front of that 4, right? It's scientific notation. So this is 0.00000047. That's what that means, okay? So if I'm going to round that to the nearest tenth, what is that? It's 0. So this would be 0, -4. Okay, so now, let me ungroup this. Now I'm going to answer all those other questions. I lost. It was like there. Okay. Let me regroup these. Okay. So now I'm going to answer all those other questions. Domain on this graph would be what? Manuel. Negative infinity to positive infinity. Good. My arrows are going to point left and right. What's range on this graph? Also negative infinity to positive infinity. They're pointing down and up, right? Determine the intervals on which the function is increasing, decreasing, and constant. And this is where your max and your min are super important, right? That's when it changes direction. So I was going first up, which means increasing. So it's increasing from negative infinity to that coordinate point, but I do the x value of it, right? Which is negative 1.3. No, sorry, that's the 0. Negative 1.1. Okay, that was my max. That's when it changes direction. Then it came down, which would be decreasing from negative 1.1 to where it stops again in that coordinate point. This one here is off my graph, but it was negative 4. So it goes decreasing until 0. And then it increases again from 0 to positive infinity. There's no horizontal line, so it's not constant in any spot. And then the rest of it we found, the relative max was that coordinate point that's negative 1.1 and 1.1. The relative min was 0, negative 4. The zeros are negative 1.3, 0.8, negative 0.8, and positive 0.8. And is the function even, odd, or neither? Neither, okay? 1, I look at that graph, it's not symmetric to the y-axis and it's not symmetric to the origin. 2, if I plug in a negative x and it's not going to go away. If I plug in a negative x and a negative y, some of it changes, but not all of it. So this would be a neither. So this, again, this is how you start your test. The more comfortable you are with your calculator, the swifter you go through this, the more time you allow for the rest of your test. If you are sitting here trying to figure out how to use your calculator that day and you waste too much time on this, I'm going to keep nagging you. I'm going to be like, dude, you're not going to finish your test if you keep on this first part. So you got to watch your time, okay? And that comes with practice. Adam.
So this whole thing we did right now would essentially be worth 25 points?
Correct. Yep. Questions before we get into the rest of the review? How
much time do you have?
You'll have the whole class period. So like you walk through the door, you start. Yeah. And what day is that? That's Tuesday. So I have you guys after lunch. Don't be late.
Is this the only calculator part?
Yes. Then you will put your calculator away, and then you will start the second part. Okay. That's kind of what this stuff is. So I sent this to you or you downloaded it so that you have it. If you did not, like if you couldn't, feel free to take a picture of it and do what you can so that you don't have to rewrite everything. Yeah, you just go out of it. But I would send that to, remember I said before, send it to Notability. So now that you know what you've done, you did is correct or you changed it on there, that which is fine, send it to Notability so you have it later to practice. All right, so we started in B1 with your distance formula and your midpoint formula, okay? We use this with the circles. We use this with the sides of a triangle to classify that kind of stuff. So that's what you need to know from B1. Distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared, and the midpoint x1 plus x2 over 2, y1 plus y2 over 2. It's not going to be a straight up get the distance of this or the length of this. It's going to be an application. So it's going to be in your circle, like here's the endpoints of your diameter like it was in the quiz, and you have to find your midpoint. That's how that's going to show up, okay? B2 starts the same way as it did in your quiz. It's going to tell you to find the intercepts and the symmetry of an equation, and then it's going to tell you to graph it. So for our x-intercepts, we plug 0 in for y, and then we solve for x. And for our y-intercepts, we plug 0 in for x, and we solve for y. If that gives you enough information to graph, then graph it. If it doesn't and you need extra points, do it quickly, but you can plot some extra points, okay? Then came symmetry. So our test for x-axis symmetry is to plug in a negative y. Our y-axis symmetry is to plug in a negative x, and our origin symmetry is to plug in both negative x, negative y. Once we've plugged it in and simplified it, we check. Does it go back to the original, or is every single sign the opposite of the original? If either of those happen, then our symmetry test passes. It's a yes. If it do not, it's a no. Questions so far? And again, then you'll have an equation to graph. So you're going to find all that information and then you're going to graph. Then came finding the equation of a circle given the endpoints, right? So this got a little sloppy on the quiz just because of like simple mistakes, not the overall, not knowing what to do in general. So you want to be really careful with this. So if I gave you the endpoints of the diameter, I would do 5 plus 7 over 2 and negative 3 plus 1 over 2, which is 12 over 2, negative 2 over 2, or 6, negative 1. And then that's the midpoint, which is also what, if it's a diameter? The center, good. So I already have x minus 6 squared plus y plus 1 squared. That part of my equation is already done. Then I want to find the radius, and we had choices. We could either find the length of the diameter and cut it in half, which is where some silly mistakes happened because there was like a fraction, a square root in it, right? Or we plug this in. So if you plug in either point, so let's say I'm going to pick the second point because they're both positive, I would get 7 minus 6 squared plus 1 minus a negative 1 squared equals r squared. This would be 1 squared plus 2 squared, 1 plus 4, which is 5, equals my r squared. So if it asked for it, if it asked for the center and the radius, which I think it does, I can't remember right now, 6, negative 1, and the radius would be the square root of 5. If it just asked for the equation, I don't even need to square root the 5 because in the equation the r is squared, so that's my answer. Questions on that one? Then came find the center and the radius from the equation and then graph the circle. So this would be at negative 5, positive 3. And my radius would be the square root of 18. Can I leave it like that? No. No, you have to simplify this. This is 2 and 9, which is 3 and 3. 3 goes to the outside, so my radius is 3 root 2. Now that's my answer for the radius, but when I go to graph it, it's easier to estimate it from the original 18. So when I want to graph this, I don't think I put a graph on there, did I? No. I would go negative 5, positive 3. What's interesting is some of you graphed it in the wrong quadrant, like you went the wrong direction, so just be really careful. The square root of 18 is in between the square root of 16 and the square root of 25, which means it's in between 4 and 5. So even if you approximate it as a 4.5, it doesn't matter what the point is, you're just graphing it. I would go right, 1, 2, 3, 4, 4.5, up 1, 2, 3, 4, 4.5, 1, 2, 3, 4, 4.5. And then draw your circle as best you can. So the approximating of the square root got some of you. Be very careful. It's, again, not going to be a perfect square. Abe, you with us? All right. Then we went to 1, 1, right? So that's where your quiz stopped and the rest picked up. 1, 1 was all the graphing of the line stuff. So you had y equals mx plus b. You graphed it, found your y-intercept. Okay, remember your special cases are your horizontal and your vertical lines. The horizontal is your y equals without the x, and the vertical is your x equals without a y. That's the one that has undefined slope. Horizontal has 0 slope. That kind of stuff you just need to know to apply it later. Okay, it's not going to straight up ask you like what's the slope of a horizontal line. Remember parallel and perpendicular. Parallel lines have the same slope, and perpendicular are the opposite reciprocal. The formula for slope is y2 minus y1 over x2 minus x1. And then point slope y minus y1 equals m times x minus x1. Those are things you need to know. And this was the question that got some of you on that homework. We talked about it after it too, but just a reminder. Find the equation of a line that passes through negative 5, 4. That's A parallel to and B perpendicular to a line with the equation of 7x plus 2y equals 8. There are 2 questions here. One where it's asking if it's parallel. One where it's asking if it's perpendicular. So what do I need from this equation, the 7x plus 2y equals 8? Just the slope, and then that's it. I'm done with it. So remember, I could put this into like slope-intercept form. I could solve for y, or shortcut negative a over b, which would be negative 7 over 2. So that's the slope I use for the parallel. And then for perpendicular, I flip it and change the sign. But that's it. Then I'm done with that equation. I don't use anything else from that equation. The rest of the information comes from the point that I gave you. So negative 5, 4. So I'm going to plug that in. Y minus y1 is 4 equals m negative 7 over 2. X minus a negative 5 becomes plus 5. And then I distribute. Y minus 4 equals negative 7 halves x minus 35 halves. And then I add the 4, which would be 8 over 2. And this would be 27 over 2. It's the sloppiest 8. And then B is the perpendicular. So I'm doing the same point. I'm still using negative 5, 4. But I'm using slope as 2/7. So y minus 4 equals 2/7. X minus a negative 5 becomes plus 5. I distribute the 2/7. And then I add the 4, which would be 28/7. Now, if it asks you to graph it, obviously you need to convert that into a mixed number. But if it doesn't ask you to graph it, you can keep your B in improper form as long as it... Sorry, this is so entertaining. Okay, then came 1, 2. This was the functions. So the first thing is it a function, right? So looking at an equation, looking at a graph, looking at points, how do I determine if it's a function? So if I'm looking at an equation, what makes something not a function? Ethan. Okay, so if it's an equation format, what are you looking for? Like that's for points, right? Like if I gave you the points. But what would make it no in an equation?
Y squared to an even power.
Good. Y raised to an even power, or? Been a whole week. It's gone, huh? It's gone. Absolute value. Y can't be an absolute value. If either of those happen, it is not a function. If neither of those happen, it is. Think about what happens here, right? A y even is a parabola turned on its side, which is going to fail my vertical line test. It means the same x is going to have two y's. And an absolute value is a v turned on its side, which would fail your vertical line test. Each x would have two y's. Right? So it fails all those tests. We got into piecewise functions in this section, but just evaluating. We graphed it later, which you'll see. So if I give you f of x equals all that, and then I ask you to find f of 0, what do I do? Ethan. I got to figure out which one it goes in, right? So which range, top, middle, bottom, would 0 be in? Good. It's in this range, which means I plug it in this equation. 0 plus 1 would be 1. Then I go to f of negative 2. Where's that? It's in the same equation. Why isn't it here? It's not or equal to. Okay, so be careful. It is equal to negative 2 here. So this would be negative 2 plus 1, which is negative 1. This is like one of those questions that should be super easy and fast, and yet people get hung up on it because they haven't practiced it and they have no idea what it looks like. Don't be that person. All right, then we got into domain, right? And domain from an equation. So domain algebraically, not from a graph, is all real numbers. That's what this guy means, all real numbers, or negative infinity to positive infinity. Except those three cases. If the variable is in the denominator, and in that case I set the denominator not equal to 0. if the variable is under a square root, and in that case I set whatever's under the root greater than or equal to 0. Or if the denominator, if it's both, if there's a square root in the denominator, then I set that greater than 0 because now it can't equal 0. And domain from an equation is going to be given in interval notation. Okay, so again, if that's what you need to practice, make sure you practice the interval notation. Questions on that? Okay, then came the difference quotient, right? Which is what? What's the formula I plug it into? Good. Minus f of x over h. Good. So I take, the first part is f of x plus h, right? I'm going to take and plug it into both x's. So I get 4x plus h squared minus 2x plus h plus 1. Now we have done x plus h squared so many times that you may know it already, which is fantastic, okay? If you don't, then you have to expand and FOIL it. But if you remember it, it's x squared plus 2xh plus h squared. Then I distribute minus 2x minus 2h plus 1. I distribute the 4x squared plus 8xh plus 4h squared minus 2x minus 2h plus 1. No like terms there, so that whole thing stays as f of x plus h. Then I subtract from it f of x. And this was the most common mistake you made in homework, not distributing this negative to all three terms, so be careful, okay? That becomes minus 4x squared plus 2x minus 1. I also saw this, like you lining it up, minus the 4x squared plus the 2x and minus the 1. Totally fine, however it works for you. So these cancel, and these cancel. Everything without an h should cancel. If you don't get that to cancel, you did something wrong. We also forgot to distribute the 4 in, like there was a 3 on the homework and some of you forgot to distribute the 3. So I have 8xh plus 4h squared minus 2h all over h. And then my h's cancel. And I get 8x plus 4h minus 2. If you know what you're doing, you can do this question quickly, which saves you time on the rest of the test. If you're trying to figure out how to do this question while you're taking your test, it's going to kill you. Questions on difference quotient? All right, 1, 3 was domain and range from a graph. So we go left to right from our graph on domain, range, bottom to top. This is also in interval notation. Domain and range, remember, usually you're looking for open dot, solid dot, that kind of thing. Solid dot is a bracket, open dot is a parentheses. Increasing, decreasing, and constant. Again, interval notation, just the x values. So we're going just the x from left to right of the increasing, decreasing, and constant. Remember, most of the time it's parentheses. The only time it's not is when you start or stop constant. The zeros are where we cross the x-axis. When you're giving zeros, you list just the x values, so it's not coordinate points. The max and min is in a coordinate point, okay? The max is every peak, the min is every valley. This will be an x, y, just like we did on the warm-up question. And then if it asks for where that graph is greater than or equal to 0, I'm looking for where it's above the x-axis. So if I, picture what we had for our graph, like this. If I want to know where it's f of x is greater than 0 or greater than or equal to, I'm talking about all these points and all those points. So this was like negative 1.1 and this was negative 0.8. It would be greater than or equal to 0 from negative 1.1 to negative 0.8 with a bracket on both because it's or equal to. And then also again from this was 0.8. 0.8 to positive infinity. And then came even and odd. Even symmetric to the y-axis, odd symmetric to the origin. Wait, that's not true. Origin, cross that out, guys. It's origin, not x-axis. This is right. You do x to negative x and y to negative y. So this is if you can fold it diagonally. Questions on that? All right, the name, graphing piecewise function. So this got messy in homework too. This says f of x equals 2x minus 1, where x is less than negative 1. F of x equals 3, where it's in between negative 1 and 2, including the negative 1 but not the 2. And x squared plus 3, where x is greater than or equal to 2. So when I taught you this, I told you have two options. Either graph the full graph of whatever it is and then erase the part that doesn't apply, or plot in points and only graph from the range you're given. So I'm going to do both, okay? If I want to graph like my full graph and erase, I'm going to start with the line. Y equals 2x minus 1 has a point at negative 1, up 2 and to the right 1, or down 2 and to the left 1. I would draw my line. And then it's only true for where it's less than negative 1. So I would go to this point, less than is an open dot, draw it left, and erase all the rest of it. And again, that's an open dot because it's less than, not less than or equal to. If I go to the next one, which would be y equals 3, this would be a horizontal line through 3. And it says this is true for where it's negative 1 to positive 2, including the negative 1, which would get the 0, which would get the solid dot, and up to positive 2, but not including positive 2, so that's going to get the open dot. All right, and then the last one, which is y equals x squared plus 3. Now, when we did this section, we hadn't done the transformations yet, right? So you would have had to plot some pretty specific points in there, user symmetry, that kind of stuff. But now you have your transformations. So x squared plus 3 is what kind of graph? It's a parabola with what transformations? It's 3 units up. So it would look like this, right? Or that's our approximation. But this says where it's greater than or equal to 2. So I actually have to figure out what is happening at 2. Where is this point here? And to do that, I plug it in. So 2 squared plus 3 would be 4 plus 3, which is 7. So my actual coordinate point for this would be 2, 7. It's solid because it's or equal to. And then I would want to find the next point so I know what's happening. I know it's going up, right? But I don't know how high. If I plug in 3, 3 squared plus 3 is 9 plus 3, which is 12. So the next coordinate point would be all the way up here at 3, 12. If it goes off your graph, it goes off your graph. Just plot your point. It doesn't matter. Questions on piecewise? Graphing piecewise. Casey.
For the parabola, are they connected or are they separate?
Is this one, it should be one curve, is that what you mean?
Yeah.
Yeah, I just drew on top of it, but yeah, it's just one curve. And it starts solid because it's or equal to at the beginning. These can be any kind of graphs. You could get a square root in there, you could get absolute value in there, you can get a line, you can get a parabola. Because now that you've covered all those parent functions, you could literally see anything there. Okay, the other way to do it is literally plot some points. So if I know this is less than negative 1, I can plug in negative 1, and then I can plug in negative 2. I would go less than, and then just plot those. So if I plug in negative 1, I would get 2, negative 1, minus 1, negative 2, minus 1, which is negative 3. So I would know that point is there. Then I would plug in -2, -4 minus 1, which is -5. Then I would know that point is there. Okay? Then the horizontal is always 3. There's no points that you need to plug in there. And then the one on the right, the parabola, we already plugged in points. Okay? But you would do that. The transformations. So you need to know how to graph. X squared, obviously that's our parabola, right? V, absolute value. Square root is that curve that points to the right. A cubic function, which goes up to the right, down to the left. And a reciprocal function, which is up in the top right corner and the bottom left corner. Now, I did not put this on the regular test. I have not made the makeup, so I'm not making any promises on that because I'm going to run out of parent function at some point. But I didn't put the reciprocal function on your test. You're going to have to find domain and range of all these. So like the question that we practiced at the end of the notes yesterday, it's going to say find the parent function, tell me, describe the transformations, and then graph it, and then give me domain and range. So the plus or the minus at the front does what? Good. Flips it upside down, right? Or symmetry across the x-axis. So a negative flips upside down. What's the number in front of the parentheses, square root, absolute value sign? What's that do? It's your vertical stretch or shrink, right? It makes it narrow or wide if it's a whole number. So if it's greater than 1, then it's a vertical stretch. It makes it narrow. If it's a square root, it makes it tall. If it's less than 1, so we're talking a fraction, then it's a vertical shrink. Dylan, you have a question?
On the test, it's right, like on the homework, it's a shrink or a stretch.
Yep, you're going to describe the transformation, and then on the graph, if it's a stretch or a shrink, you're going to write right on it. So I know that you intended it to be skinny. Because you're not graphing a parent function and then that, you're just graphing the one that's transformed.
Are you going to tell us to describe the function?
Yeah, yeah. The plus and minus inside the function does what? Goes left or right. So if it's positive, it goes right. If it's negative, it goes left. Unless there's a negative on the x, right, inside the parentheses, then it flips it. And the number that's separated by a plus or minus, either at the front or the back, is what? Good. The vertical shift. So up if it's positive, down if it's negative. You're going to get multiple transformations in one equation. It's not just going to be one thing. So just be prepared to do all that stuff. And then find your domain and range. And then the last thing is an equation from a graph.
Plus moves it, it's inside the parentheses. I thought plus moves it left.
It does. Oh, I wrote that wrong. Did I say it wrong too? Plus moves it left. Minus moves it right. Thank you. Unless there's a negative here. If there's a negative on this, remember that flips that. Changes it the other way. Okay, equation from a graph. So first of all, what kind of graph is this? Square root. What are my transformations?
1 up and 2 to the right.
Good. 1 up, 2 to the right. So what's it look like in the equation?
1 plus the square root of x minus 2.
X. Oh, okay, so you're putting the 1 at the front. That's fine. Minus 2. So it could be 1 plus square root x minus 2, or it could be square root x minus 2 plus 1. F of x equals. Okay, either of those works. I told you yesterday, but I'll say it again. There's no non-grid transformation, so there's not anything you're going to have to try to figure out if it's stretched or shrunk. But there could be a reflection. There could be a shift right or left. It could be up or down. Helen.
What's the difference between it being like under, like, because on the top it was like x plus h. Yeah. Wait, I don't understand how to ask my question. Because like on the one you just did, it was like under the square root. Why can't you just put it in parentheses?
And not put a square root?
No, like the square root x and then minus 2.
That's a vertical shift.
Oh, okay.
Yeah. So if it's not under it, it's a vertical shift. If it's under it, it's the horizontal shift. Questions? All right, so I'm going to publish your review for your test. It's not graded because I put the answers right on it. So that's for you to, I mean, hopefully we know enough to know that we need to do a review before we go into a test blindly. Your goal is to do as much of it as you can tonight so that tomorrow you come in knowing what you have questions on. And then tomorrow I'll answer questions on your review, okay? There's no time for questions in class on Tuesday. There's no time for telling you how to use your calculator on Tuesday. It is a walk through the door and start your test scenario, okay? And remember, it's a long weekend, so I don't see you Monday. So it's so important, I would say, do as much of the review as you can tonight. If you're swamped, it's fine to wait on all of it. You don't have to do all of it. But at least know what you know and don't know tomorrow.